So today is the 10th of June 2020, and today we're moving on to constructing a line graph. So yesterday we looked at interpreting and reading a line graph, and today our focus is on constructing a line graph, so drawing a line graph. So write down today's date and learning intention, and let's get started. As per usual, you will need a pencil, paper, thinking hat, worksheet that was emailed to you, and if you'd like to do some extra work, you could go on to mathematics. So I did say that this week we'd be focusing on percentage and finding a percentage of an amount. So yesterday's one, we went over a few different percentages. Today we're going to focus on multiples of 10. So finding 50% should be easy. That's just the same as finding half. Remember, 100% means a whole. So 50% is our half. 10% is the same as finding a tenth of. So we just divide that by 10. So just as we did yesterday, the numbers that you're finding a percentage of matches the advice given on the outside. So first of all, you need to find 50% of 80, which is the same as half of 80. And then the same for 140, 56, and 300. To find 10% of 80, you need to divide that by 10. To find 30%, you use what you know about dividing by 10 to find 10%. Once you've got that 10%, to get from 10 to 30, we have to multiply it by 3. So to get from whatever your answer is to 10% to 30, you also have to multiply that by 3. So I'll stop talking, and I'd like you to pause the video here and set your 10-minute timer. Check. So here are our answers shown on screen. We'll go through one row together, and then you can just mark down the answers on the others as you see. So 50% of 80, we know to find 50% you need to find half of the amount. So half of 80 is 40. 10% of 80 is 8, because 80 divided by 10 is 8. And then we take that same 8 and we multiply it by 3. So 10% is 8. And then to get from 10 to 30, we multiply by 3. So we multiply 8 by 3 and we get 24. 40% of 80 is 32. 60% of 80 is 48, because we do 8 times 6 and we get 48. And 70% is 56, because 7 times 8 is 56. So well done if you managed to get that. It's the same for the ones where you might have had a decimal number. So with 56, for example, we know that 10% of that is 5.6. So you're doing the same thing, but you're just multiplying instead a decimal number. And you have to remember to line up your decimals. So wherever your decimal is, when you write your written column method or written method for multiplication, the decimal needs to go in the same place in your answer. So well done if you managed to get those. Now, Twinklville and New Twinklton is what we're going to be focusing on these areas for the next few slides. Twinklville is a small village in the countryside, and the nearest town to Twinklville is called New Twinklton. Have you ever been there? I bet you haven't. Now, the line graph is going to show the population of the two locations over 8 years. The population means how many people live there. So, if you have a look at our line graph, you can see that the information for New Twinklton is shown in green, and the information for Twinklville is shown in purple. And there's a key on the graph which tells us that. So where New Twinklton has been written, we have a green line, and that tells us that the green line on the chart, on the graph, represents New Twinklton. If we look at the title of our line graph, again, that gives us information about what the line graph shows. So it shows the population, Twinklville and New Twinklton over 8 years. The population is recorded in millions. It's been rounded to the nearest million. Now, looking at this line graph, what was the approximate difference in population between Twinklville and New Twinklton in 2003? So, we need to find 2003 on the x-axis, labelled years. Can you put your finger on it? Excellent. Now travel up to the purple line for Twinklville, and we're going to work out what the population was in Twinklville in 2003. But actually, before we do that, we're going to take a step back. We need to work out what these increments represent. So between 5,000 and 10,000, what do these lines in between represent? Well, we can see that there is 1, 2, 3, 4, 5 of them. Okay, so we know that there are 5 of them, and it's between 5,000 and 10,000. So we know that that could be, most likely, it's going up in thousands. Okay, and we can do that because we know that there's a difference there of 5,000, and 5,000 divided by 5 is 1,000. So now we know we're going up in thousands. So if we look at where our purple line is in 2003, going from 5,000, we're going to count up in thousands. 6,000, 7,000, 8,000. So there was a population of 8,000. Population of 8,000 in 2003. Now let's go up to the green line. What was the population in 2003 in New Twinklton? Well, go from the number shown just before, so that was 20,000, so then 21, 22, 23,000. So Twinklville had 8,000 and New Twinklton had 23,000. What is the difference? Well, from 8,000 to 23,000, the difference is 15,000 people. In which year did Twinklville's population reach approximately 10,000? So the way to do this is to find 10,000 on our line graph and then follow it along until we reach the purple line, and then we change direction and go down until we've reached our x-axis, and we can see it was in 2005 that Twinklville's population reached 10,000. Now, in which year did the population of Twinklville first rise above approximately 10,000 people? So, which line represents Twinklville? Excellent, it's the purple one. So let's follow the purple line and let's see at what point it rises above 10,000. So follow your finger along the purple line, and when that purple line hits 10,000, I want you to stop and change direction and follow the vertical line down to the year. What year was it? Excellent. It was 2006. Okay, that's when it rose above. So that one might have been a bit tricky. If you stopped when it was 10,000, then you might have got that wrong. It had to be above 10,000. So it wasn't until 2006. Now, the United Twinkledom is made up of 3 different countries. Twinkleland, have you been there? Twinkleonia, have you been there? And Twinklemark. In the United Twinkledom, a census has been taken every 10 years. And so what a census does is it counts all the people in the country on a particular day. The only time that the census was not taken was in 1941. The table shows the census data for the whole of the United Twinkledom from 1931 to 2011. So you can see in 1931 the population was 45 million. In 1941 we don't know what the population was. But in 1951 the census showed that there were 50 million people living in Twinkledom, and so on and so forth. Now, Megan identifies that the table of data shows the change in how many people were living in the United Twinkledom, which can be abbreviated to UT, over 80 years. She knows that a line graph can be used to show changes to a variable over time, so she decides to draw one. She also knows that a line graph has a horizontal and vertical axis, and that the time data is usually shown along the horizontal axis. So if we're trying to show time, we use the horizontal axis to record the time. Now, looking at the table of data, what scale interval would you use on the horizontal axis and the vertical axis? So you can see the horizontal axis, which is going to be the years, goes from 1931 to 2011, which we know is 80 years. So what would you choose to go up in? Would you go up in fives? Would you go up in tens? What would you choose to go up in? And then I want you to think about what the vertical axis, our y-axis, is going to increase by. It's going from 45 all the way to the number 63. Megan decides on a 10-year interval scale for the horizontal time axis and a 2 million interval scale for the vertical distance axis. We know that the y-axis, we can make the numbers smaller because there's only a small difference between the numbers. While she's creating the scales, Megan makes sure that the numbers are positioned on the lines of the axis. So the numbers shouldn't be in the middle of a box. They go at the end of a line. Okay, following the line. She doesn't label every interval on the axis. Megan's line graph also needs a title. What do you think would be a good title for this line graph? Brilliant. She chose a line graph to show the population of the United Twinkledom from 1931 to 2011. Perfect. That summarizes exactly what this graph shows. So remember, your title always just needs to be clear. It needs to show anyone that's looking at it, what information will I gain from this? If they look at your title and still think, well, what does this show? Then that means your title isn't clear enough. You also have to remember to label each of the axes. Now Megan is ready to plot the data. She knows that this is similar to plotting coordinates. So she locates the year values from the data table on the x-axis. She finds where these x-axes intersect with the population values on the y-axis, and she marks each intersection with a small cross, just like we looked at yesterday, and just like this. So now she's marked all of the information on, she joins them up. Why do you think she hasn't joined up the information from 1931 to 1951? Super, it's because she doesn't have the information for 1941. There's a break in her data. she can add a dotted line to join the data from 1931 to 1951, and this will show her what the population is likely to have been in 1941. So looking at this, she can estimate what the population is likely to have been, but we don't know for sure. So the dotted line represents the estimated population. Now we're going to think about how we can use our knowledge of line graphs to help answer Megan's questions about the population of UT, or United Twinklton. In which decade, we know that's a period of 10 years, in which decade did the population of the UT increase the most, and how can you tell? So look at the line graph, and you might think there's two hats you can use to answer this question, and in fact you probably need both of them. You need a logic hat and you need your method hat. Okay, so logic hat, how will you know which decade had the greatest increase? That's right, it's going to have the steepest climb. And then you can use your method hat to work out the calculations. So the population increased the most between 2001 and 2011. We can tell because this section of the graph looks like it has the steepest line. When we check using subtraction, these 2 years have the biggest difference. Remember, that's the amount from between one number to another, and if we subtract the lesser one from the greater one, we find the difference in population, which is an increase of 4 million people. So from 2001 to 2011, there was an increase of 4 million people. Now you'll see that between 1931 and 1951, now let's have a go answering another of Megan's questions. Between which years does the graph show the population stayed the same? Do you think it did stay exactly the same? So have a look. How will we know if it stayed the same in that decade? How will we know? What are we looking for? Are we looking for a line that's going up? Are we looking for a line that's going down? Or are we looking for a line that stays the same? That doesn't go higher or lower, but it stays the same. Yep, that's exactly what we're looking for. So between the 2 points, there will be a line which stays exactly the same, meaning that the number stays the same. Have you found it? Excellent. The graph shows that the population stayed the same between 1971 and 1981. However, the population is in millions. It's rounded to the nearest million, so it could have changed between 55 million and 56,499,999. And it would still be shown as 56 million on the graph, because remember, we're rounding it up. So it is unlikely it stayed exactly the same. Okay, it's very, very unlikely, because people are having babies all the time. Okay, so it's unlikely that it would have stayed exactly the same. Can you think of a reason that the census may not have been carried out in 1941? Can you think of a real-life event that might have stopped them from carrying out a census in that time? Here's a little hint. Think about an event that you have been learning about that lasted between 1939 and 1945. What event could have stopped them from carrying out a census in that time? What do you estimate the population might have been from the graph? So, I know you probably all got this one. 1941, which is the year that the census should have been carried out, was right in the middle of the Second World War. It could have been so many of United Twinkleton's resources were engaged in this war, and that they were unable to carry out the census that they usually do. From the graph, though, we can estimate that the population in 1941 was approximately 48 million. Okay, because we follow the line along from 1931 to 1951, and then it's fair to say that it's likely to have been about 48 million based on where that line hits 1941. So, excellent work on interpreting and now drawing line graphs. So, thinking about all those things, making sure that we've got the appropriate spacing between each interval, that we place the numbers on the lines and not in the spaces. I want you to now have a go at constructing your own line graphs. And you're going to use these to help you solve some of the problems as well. Okay? If you finish that, easy peasy, then you can go on to mathematics and have a go at your statistics right there. However, I think if you're starting from level 1 and you find that easy, then do just have a go at the level 2. For this one, you probably will need to print off the work shown on screen because the graph is on the sheet for you, so you probably will need to print that off. So if you can't print it off, then you'll need to then draw it in. That's the only other alternative, is to look at it and to then draw it in. But if you can print it off, then please do. Remember, as always, to email us your work at yr6@grange.harrow.sch.uk. Have a fantastic day,